Hi all, let's see the Compton effect topic. So Compton effect topic is a quantum mechanics subject. It was discovered by the Compton in the year 1923, and he earned the Nobel Prize for this. Is 1927 he earned the Nobel Prize. It's an inelastic scattering method. So what happens is actually the fast moving X-ray strikes the fast moving X-ray strikes the target. It is the incident photon. Of energy E is equal to h nu. It's a monochromatic ray, maybe it may be X-ray or gamma ray. The fast moving incident photons of energy E is equal to h nu strikes the scatterer. So the rays are scattered in all the directions. If you observe the scattered ray, the energy is decreased, E is equal to h nu dash. The frequency is decreased, but if you are saying in another time, the wavelength is increased. So what happens is, here there is an electron at rest. The electron at rest. The equation for its rest is E is equal to m naught c. After the collision with this incident photon, the electron is ejected out, and it is called as recoil electron, and the energy of this equation is E is equal to mc square. By the law of conservation of energy, we can say this as the energy before collision and the energy after collision. So what happens, see, the incident photon strikes the scatterer. The rays are scattered in multiple directions, all the direction, and if you observe the wavelength of the scattered ray, the wavelength is increased, or the frequency is decreased and the energy is decreased. Why it's happened means, the electron initially is at rest, and the energy is absorbed by the electron, and the electron is ejected out by observing the energy of this incident photon. So the energy is changed to E is equal to m naught c is at rest, and then it's changed to E is equal to mc square. The energy is changed. So by the law of conservation of energy, let us discuss how the wavelength is increasing. So it is scattered in the angle theta, and the electron is moved in the angle of phi. This is the basic concepts, and some of the ray having the same wavelength, they are called as the unmodified radiation. Having same wavelength without change in wavelength is called unmodified radiation. Unmodified radiation. Here there is a change in wavelength, it is called as wavelength is called as modified radiation. Modified radiation. The difference between these two is nothing but it is lambda dash minus lambda is dull lambda is called as Compton shift. I once again repeat this concept. See, the incident photon, maybe the X-ray or monochromatic ray, strikes that scatterer. The scatterer, what happened after the collision, the electron initially is at rest, the energy E is equal to mc square, and is ejected out with the energy recoil electron E is equal to mc square, and the rays are scattered in multiple directions. So the scatter light have the decrease in frequency, or if you are saying in wavelength, there is an increase in wavelength. So some of the ray have the same wavelength. They are called as without change in wavelength. They are called as unmodified radiation. Unmodified radiation, and change in wavelength, it is called as modified radiation. The difference between these two, lambda dash and lambda, is nothing but the dull lambda, which is nothing but the Compton shift. Let us derive. It depends on what factor. So, by the law of conservation of energy and momentum, we are going to derive this Compton shift. It is an incident photon of energy E is equal to h nu and momentum h nu by c. Here initially the electron is rest. The equation is E is equal to m naught c square, and it is a scattered ray. E is equal to h nu dash, momentum is equal to h nu dash by c. It is scattered with the theta angle and the electron is ejected out. So, it is called as recoil electron with the energy E is equal to mc square. It makes an angle phi. It is an inelastic scattering. So, first initially by the energy concept, so we are by the law of conservation of energy, we know the before collision is equal to energy before collision is equal to energy after collision. So, it is energy before collision, energy before collision. Here we have two energies. One is the incident photon energy E is equal to h nu, another is the electron at rest, the energy is m naught c square. So, first one, energy of the incident photon, energy of the incident photon, the equation is E is equal to h nu. Next one, energy of the electron, it is at rest. So, electron at rest, E is equal to m naught c square. So, energy before collision, we can add both the thing. So, it is nothing but energy before collision, we can add both the thing, h nu plus m naught c square. Next one is energy after collision. The next heading is energy after collision. So, what happened after the collision? The electron is recoiled and the photons are scattered. So, the first one is energy of the incident photon. So, similarly here it is the energy of the scattered photon. Energy of the scattered photon. What's the equation? It is E is equal to h nu dash. We know the frequency varies and the frequency decreases, the energy also decreases. So, therefore, it is h nu dash. Second one, the recoil electron. So, the energy of the recoil electron is, the equation is E is equal to mc square. So, we can add both the thing. So, energy after collision, we can add both the thing, it is h nu dash plus mc square. See, we all know by the law of conservation of energy, energy before collision is equal to energy after collision. So, we can equate these two equations. By the law of conservation of energy, energy before collision is equal to energy after collision. So, we can equate these two equations, this equation and this equation, which is nothing but h nu plus m naught c squared is equal to, here we have h nu dash plus it is mc squared. This is the very important equation. Let us name it as 1. So, by the law of conservation of energy, we get the energy equation. The before collision equation is h nu plus m naught c squared, and after collision is h nu dash plus mc squared. Similarly, we will find the equation for the momentum. Slightly we can change this diagram. So, what we are doing is here so now we are going to find about the momentum. Okay. So, we are dividing the momentum into two components, x component and y component. So, initially we find the momentum for the x component. So, here it is the x component of momentum, and here it is the y component my, and this side it is minus my. So, to find this one we can name the thing, it is A, B, C, D, okay, E. So, initially we find the x component of momentum. X component of momentum before collision. Okay, x component of momentum before collision. This is a heading. Here we have two things. One is the incident photon, another is the electron at rest. So, first one, x component of momentum of this incident photon So, what is the equation? See the diagram, it is P is equal to h nu by C. So, it is h nu by C. That is the first one. Second one, x component of momentum of electron at rest. So, what will be the equation? Electron at rest. We have the keyword, it is in rest. So, there is no momentum at all. So, it will be 0. Yes, the electron at rest means, see it is a keyword rest. The rest means there will not be any momentum. So, it is 0. So, we can add together. Therefore, total x component of momentum, x component of momentum before collision, we can add both the thing. So, we get h nu by C plus 0. right. The next one we will find for the after collision. X component of momentum after collision. So, in this after collision we have two things, one is a scattered photon, another is the recoil electron. So, the momentum of the recoil electron is nothing but mv, we all know it is mv, and for the scattered photon is h nu dash by c. So, the x component of momentum after collision. So, here the first thing is x component of momentum of the scattered photon, scattered photon. See, we are finding for the x-axis, but it is not scattered in the x-axis. So, here we have theta. So, from the triangle we can find, from the triangle OAB. So, from the triangle OAB, so we want to find the x component of momentum here, this side. We want to find OB. So, we can use the cos theta is equal to mx by h nu dash by c. So, we need the x component of momentum, therefore, mx is equal to h nu dash by c into cos theta. So, once again repeating this one, we are finding for the x component of momentum, but it is scattered in any direction. So, by the angle theta from the triangle OAB, we can find the x component of momentum in the x axis. So, by using this triangle OAB, so cos theta is equal to, here it is a mx. So, it is in the adjacent side, so that we can cos theta is equal to mx by h nu dash by c. We want to find mx. So, therefore, m suffix x, that is momentum along the x axis, which is equal to h nu dash by c into cos theta. Similarly, we want to find for the recoil electron x component of momentum of recoil electron. So, the electron is also not in the x axis. So, same from the triangle, So, here now we have OBC. By the angle phi. Similarly, the momentum along the x axis is in the adjacent side. So, again we can use the cos phi. Cos phi is equal to mx by, here the momentum of the recoil electron is mv. So, we want to find mx, momentum along the x axis. Therefore, mx is equal to, just cross multiply this one, mv into cos phi. Is it right? Now, we can add both the thing. So, total x component of momentum x component of momentum, this is before collision, next will be the after collision. After collision, yes, we can add both the thing, just nothing but h nu dash by c cos theta plus it is mv cos phi. So, the next is, now we got the answer for the x component of momentum before collision is h nu by c plus 0, and for after collision is, it is nothing but h nu dash by c cos theta plus mv cos phi. So, by the law of conservation of momentum, we know it is the momentum before collision is equal to momentum after collision. So, we can equate both the thing. Momentum before collision is equal to momentum after collision So, we can equate both the equation. Here we have h nu by c, but this side we have h nu dash by c cos theta plus mv cos phi. Is it clear? Just we can box this one. It's equation 2. Let's say we got the equation 2. Next we want to find for the y component of momentum. So, I once again explain for the x component. See, the incident photon is passing on the x axis. So, the x component of momentum for the incident photon is, from the diagram it is seen, it is P is equal to h nu by c, and the x component of momentum of the electron at rest. So, the electron is rest means there will not be any velocity. So, therefore, it is 0. It is 0. Total x component of momentum, we can add both the thing. So, we get h nu by c plus 0. Similarly, for the after collision, see, it is scattered in the any direction with the angle theta. So, here we have the x component of momentum. So, by using the triangle OAB, so theta, so it is in the adjacent side, we are using the cos theta. So, cos theta is equal to mx by h nu dash by c. Need to find the x axis, momentum along x axis. Therefore, mx is equal to, just cross multiply these two things, h nu dash by c into cos theta. Similarly, for the electron, here we have the recoil electron with the angle phi, and we want to find the momentum along the x axis here. So, by using the angle phi from the triangle OBC, cos phi, again cos phi is equal to adjacent side. So, mx by the momentum component is mv. So, mx by mv, we want to find mx. So, mx is equal to mv cos phi. We are adding both the thing. So, we get h nu dash by c cos theta plus mv cos phi. So, by law of conservation of momentum, momentum before collision is equal to momentum after collision. So, we are adding both the thing. Here it is, before collision is h nu by c, and then after collision is h nu dash by c cos theta plus mv cos phi. Okay. Similarly, we want to find for the y component. So, y component of momentum before collision. So, y component of momentum of incident photon, what will be the answer? See, the incident photon, X-ray is passing us only in the x-axis, not in the y-axis. See, this is the y-axis, so not in the y-axis. So, what we can write? We can write as 0. So, the y component of momentum of incident photon is 0. Similarly, the next line is the y component of momentum of electron at rest is already 0. It's a 0. Therefore, total y component of momentum before collision is, so here it is 0. Is it clear? So, once again I am saying the y component of momentum of incident photon is 0. Since the X-ray is passing only on the x-axis, not in the y-axis. This is y-axis. So, we are not passing in the y-axis. So, it is, the answer is 0. And already the electron energy is also 0. So, therefore, y component of momentum before collision is 0. Clear? Next one is y component of after collision. So, y component of momentum after collision. So, first we want to find for the scattered one. Let us rub it entirely. Here that will change. Yes. So, y component of momentum of scattering photon. So, where is the y axis? Here. Now we want to find this one, the momentum along the y-axis. We want to find this one. So how we can take here, if we have theta means this opposite angle is also theta, right? And similarly here we have angle phi means this side is also phi. Yes. So by this concept, now we want to find the y component of momentum of scattered photon. So what triangle we can take? O, A, E. So from the triangle O, A, E. For theta it is in opposite side, so we can take sine. So sine theta, here we have theta. So sine theta is equal to opposite side is my. Opposite side by adjacent side, it is nothing but h_u dash by c. We need to find momentum along y-axis. Therefore, my is equal to h_u dash by c into sine theta. So similarly, we want to find for the next one, recoil electron. Y component of momentum of recoil electron. So for which triangle? From the triangle. So now we have phi here. So let us take the triangle OCD. OCD. The phi is opposite this one, this minus my. Let us see the diagram. Here we have the positive y-axis, so it is plus my. But here it is a negative y-axis, so it is minus my. So from the triangle, it is opposite to the angle. So again we are using the sine phi. Sine phi is equal to opposite side, it is minus my by the adjacent side is mv. We need momentum along y-axis only. We need only my. Therefore, momentum along y-axis is equal to my is equal to, let us change this minus this side. So minus mv sine phi. So the first one is for the scattered photon, it is h2 dash by c sine theta, and for the recoil electron it is minus mv sine phi. Don't forget this minus, since here it is on the negative y-axis. So we can add both the thing. Therefore, total y component of momentum, y component of momentum after collision is equal to, we can add both the thing. So what we have for the scattered photon is h nu dash c sine theta, and for the recoil electron is minus mv sine phi. So what happened? We know by the law of conservation of momentum, the momentum before collision is equal to momentum after collision. So we can add both the thing. This is before collision and this is after collision. Therefore, by the law of conservation of momentum, momentum before collision is equal to momentum after collision. Momentum after collision. So let us add these two equations. The before collision answer is 0, since the incident photon is passing on only in x-axis, not in the y-axis. So therefore, before collision is 0, and after collision is, we can add this to equation, h nu dash by c sin theta minus mv sin phi. Yes, this is equation number 3. So, with this 3 equation only, we want to find the what is Compton shift. So, I once again explain this for this y axis. See, initially the incident photon is passing only in the x axis and not in the y axis and not in the y axis. So, therefore, the scattered photon is in the somewhere by the angle theta. Here it is theta, means the opposite side is also theta. For theta, this y axis is in opposite side. So, we can use sin theta. For sin theta, it's opposite adjacent side. So, it is my by the adjacent side is h nu dash by c. So, therefore, we get h nu dash by c into sin theta. And for the recoil electron, it is minus y axis. So, it is minus my. So, here it have the angle phi. This side is also phi. For the phi, it is in the opposite side. Again, we are using the sin phi. So, for sin phi is equal to minus my by mv. We need only the y axis. So, therefore, momentum along y axis. Therefore, my is equal to this minus come this side. So, minus mv sin phi. By adding these two things, we get h nu dash by c sin theta minus mv sin phi. This is the after collision action. So, let us equate this two things. Before collision is 0 and after collision is h nu dash by c sin theta minus mv sin phi. Clear? So, let us add the x component momentum and y component momentum. That is nothing but second equation and third equation. So, what second equation? Second equation is x component of momentum. X component of momentum, the second equation. So, what the second equation is? H nu by c plus 0 is equal to h nu dash by c cos theta plus mv cos phi, and this is a third equation. This is for x component. Next, the y component is the third equation. 0 is equal to h nu by c h nu dash by c sin theta minus mv sin phi. So, now we are going to add the squaring and adding the second equation and third equation. What will happen if we squaring and adding these two equation? So, cos square theta plus sin square theta will be 1. Similarly, here cos phi. So, squaring on cos squared phi and sin squared phi. If you are squaring and adding these together, we get 1. So, we can simplify this equation. So, we are now adding the squaring and adding the second equation and third equation. Squaring the second equation and third equation, squaring and adding. Okay. Second and third equation. Squaring and adding this second and third equation. So, what we get here, it is, if you square this one, we get Before squaring and adding, let us simplify this one. It will be easy for us to do this equation. So we can rearrange this equation and then we can squaring and adding this equation. So what happened? So from this equation we can bring this side h nu by c. If we bring in this side we get minus h nu dash by c cos theta is equal to, it will be easy for us to squaring and adding mv cos phi. Yes, bringing to this side we get minus h nu by c minus h nu dash by c cos theta is equal to mv cos phi. And what are the common terms we have? H by c, h by c. So we can take it outside. H nu minus nu dash cos theta is equal to, and the c can be moved that side. So CEV cos phi, right? Now this is the rearranged equation of second. It is called as fourth equation. See what I am doing is, so before and squaring and adding we can simplify this equation. So bringing to this side, so what happened, we get minus. So second equation, this is a second equation. Second equation we are changing this one. So bringing to this side, h nu by c, so minus h nu dash by c cos theta is equal to mv cos phi. What are the common term we have? H and c are common. So h we can take in outside, h into nu minus nu dash cos theta is equal to, the c can be moved to this side. So CEV cos phi. Okay. So now we got the change the second equation, and similarly for third equation also. So third equation how we can change? H nu dash sin theta is equal to, we can bring it that side. So what we will get? MCV sin phi. This is the equation 5. Clearly see this fourth and fifth equation right side, what we have, the common term are MCV. And here it is cos theta, here it is sin theta. If now we are squaring and adding, means what we will get? So sin square theta plus cos square theta will be changed into 1. So easily we can eliminate some of the equations. Now we square and add the fourth and fifth equation. Squaring and adding the fourth and fifth equation. Squaring and adding the fourth and fifth equation. So if we square this equation, so what will happen? It is h, we are squaring this one, it is h squared, and this is, looking into it, it is a minus b the whole square. On squaring we get a minus b the whole square. So let us expand this one, a squared plus b squared minus 2ab. So nu squared minus, it is, now it is b squared. So nu dash squared cos squared theta, a squared plus b squared minus 2ab. So already h is in the outside. So 2ab. So now it is 2ab nu dash cos theta. Squaring and adding only we can eliminate this cos and sin and all. So what we are doing is, first we are squaring this one, it is h squared. If we square this one, what will happen? It is a minus b the format. So a squared plus b squared minus 2ab. And similarly in the right side, we get m squared c squared v squared plus cos squared theta. So squaring and adding. So similarly we can add the left side also. If we add the left side, next one, h squared nu dash squared sin squared theta is equal to see this equation, this is the left side content. So what we have squaring this one, so it is h squared, a minus b the whole squared format, we expanded this one, and the next is the left side is h squared nu dash squared sin squared theta, and the right side, coming to the right side, so what is the common term here have is mcv cos phi, here it is mcv sin phi. If you square this both the side, the common term will be m squared c squared v squared, and it is cos squared phi plus sin squared phi. So, easily we can remove this one. Now, we can include this h squared inside the term, h squared nu squared plus h squared nu dash square cos squared theta minus 2h squared nu dash cos theta. Is it right? H squared nu squared, here it is square. So, h squared nu dash squared cos squared theta minus 2h squared nu dash cos theta plus this term h squared nu dash squared sin squared theta is equal to, this term will be 1, which is changed into 1. So, therefore, we can write as m squared c squared v squared. So, what are the common terms again we have? See, here it is h squared nu dash squared cos squared theta, here it is h squared nu dash squared sin squared theta. If we add these two, what we will get? The common terms are h squared nu dash squared, and it is cos squared theta plus sin squared theta. So, cos squared theta plus sin squared theta will be 1. So, we can write as h squared nu squared. Now, it is changed into 1. So, therefore, we get h squared nu dash squared minus 2h squared nu dash cos theta is equal to m squared c squared v squared. This is equation number 6. So, now we reduce the x component of momentum and y component of momentum into a single format, h squared nu squared plus h squared nu dash squared minus 2 h squared nu dash cos theta is equal to m squared c squared v squared. Similarly, we already have the energy equation. So, let us simplify that one. So, what is the energy equation? Equation number 1. Energy equation, equation number 1, which is nothing but h nu plus m naught c square is equal to h nu dash plus m c square. This is the first equation. So, now we want to arrange in this format. So, what we can do? We can bring this h nu dash to this side. So, we get h as a common factor, h nu minus nu dash plus m naught c squared is equal to m c squared. So, what I had done is, see, bringing this side we get minus, and h are the common terms, so we can take it remove outside. So, h into nu minus nu dash plus m naught c squared is equal to m c squared. And if we compare this equation and sixth equation, so what we have is, here we have only m c squared, but here it is m squared c squared. So, we can squaring on both sides, squaring on both sides. So, it is, if we square this one, plus m naught c squared. See this equation carefully. So, if we square this equation, so what will be this term? This is a and this is b. So, a plus b the whole squared formation we want to expand. So, let us expand this one, and if we expand the right side, it is m squared c power 4. Right side will be very easy one, the left side only we have We want to do it very carefully. So now it is h squared, and if we square this one, nu minus nu dash the whole square, yes, now it is a squared plus b squared m naught squared c power 4 plus 2ab, so 2h nu minus nu dash m naught c squared is equal to m naught squared c power 4. And if we observe this term carefully, so what will happen, see, again we have the a minus b whole squared formation. See, again we have, this is a, this is b, a minus b formation. Again we want to expand this one as, let us assume this is as x, this is x and this is y. So x minus y the whole squared. So x squared plus y squared minus 2xy. In this format we want, again we want to expand. So h squared, it is a squared, nu squared, a squared plus b squared, h squared, nu dash squared, then minus 2ab, so 2 h squared nu dash. Is it right? See, this is the energy equation. On squaring on both sides, what we get is, this is one term, another term. So it is a and this is b. So a plus b the whole squared, we are expanding. So a squared plus b squared plus 2ab is equal to m squared c power 4. And if we observe this term carefully, again we have this nu minus nu dash the whole square. Again we want to expand that one. So what will happen, it is, if we consider nu as x and nu dash as y, means again we want to expand x squared plus y squared minus 2xy. So in that format, if we expand h squared nu squared, that is x squared, we expand. Next, this is y term. If you assume this as a y term, it is y squared. So h squared nu dash squared, then 2xy. So minus 2 h squared nu into nu dash. Again repeat this term, plus m naught square c power 4 plus 2h nu minus nu dash m naught c squared is equal to m squared c power 4. It will be something lengthy equation only. If you do it it will be easy. And what we want to do is, this is the reduced form of energy equation. So initially what we have, this is the energy equation, and we are bringing this h nu to this side, we get so minus h nu, and h is a common term, we can take it outside. To simplify this term and this term, so what we are doing is, we are squaring the energy equation. So on squaring on both sides, if we square this equation, we get square here, and it is m squared c power 4. See, if you observe carefully, here we have two terms. Let us assume this as a and this as b. So a squared plus b squared minus 2ab. In that format we want to expand. So h squared, so it is a squared nu minus nu dash the x, and then b squared plus 2ab, we expanded. And if we observe this term, again what we have is, it is x minus y the whole squared. So it is x squared plus y squared minus 2xy. Again we want to expand h squared nu squared h squared nu dash squared minus 2h squared nu dash plus m naught square c power 4 plus 2h nu dash m naught c square is equal to mc square. This is equation number 7. So now we got the energy equation, and this is a momentum equation. Now we want to subtract the energy equation minus momentum equation. So subtract 7 and 6. Subtract sixth equation from 7th equation. So let us subtract this one. So this will be the first equation, 7th equation, this minus this one. So let us write in the top surface, the space will not be enough. Okay, that is the energy equation. The energy equation is h squared nu squared plus h squared nu dash squared minus 2h squared nu dash plus m naught squared c power 4 plus 2h nu minus nu dash m naught c square. This is the left side of the equation 7. Then coming to this sixth equation left side, so it is minus. So 7 minus 6. So next equation is minus h squared nu squared plus h squared nu dash squared minus this minus will be changed into plus, sorry, minus, and this will change into plus 2h squared nu dash cos theta. We complete the left side, right? H squared nu squared plus h squared nu dash squared minus 2h squared nu dash plus m naught square c power 4 plus 2h nu dash m naught c squared. This is the 7th equation, and next is the minus this term minus h squared nu squared minus h squared nu dash squared, minus will be changed into plus. So 2h squared nu dash cos theta is equal to, we complete all the left side. Now coming to right side, the right side is, it is m squared c squared can be taken commonly. Here also we have m squared c squared. The remaining term here, it is c squared. The remaining term is, here it is c power 4. So if you are taking the m squared and c squared as a common term, here remaining one is c squared. So c squared, and here the common remaining term is v squared. So c squared minus v squared. Okay, what are the common terms we can cancel? It is h squared nu squared minus h squared nu squared. Here it is h squared nu dash squared, it is also minus h squared nu dash squared. We can cancel the common terms, and the next term what we have the common is 2h squared nu dash 2h squared nu dash cos theta. So we can take the common term. So minus 2 h squared nu dash as a common one. So what the remaining term we get is 1 minus cos theta. Okay, the next term is m naught squared c power 4. Here we already had taken the minus 1. So this plus will be changed into minus, right? Minus into minus again change into plus. Therefore, so minus 2h squared nu dash we have taken as a common term. The remaining one is, here it is 1, and for this term it is minus cos theta. Let us write the remaining term m naught squared c power 4 plus 2h nu minus nu dash is equal to m squared c squared minus v squared. So now we got the maximum, we have reduced all the equation. So now by using the theory of relativity, we want to find what is the relationship between m and m naught. So after knowing the relation between m and m naught only, further we can reduce this equation. So from the theory of relativity, let us mark this equation as this is 7 and the reduced form is 8. Okay. Now from the theory of relativity, from the theory of relativity, we know the equation m is equal to m naught by root of 1 minus v squared by c squared. And squaring on both sides, squaring on both sides, on squaring, so what will get, m will be changed into m square and the root will be cancelled, and taking the common LCM, if you taking the common LCM, what will get, m naught by c squared minus v squared by c squared. We can bring this c squared to the numerator, so m squared is equal to m naught c squared by c squared minus v squared, and we can cross multiply these two terms. If you cross multiply these two terms, we get m squared c squared minus v squared is equal to m naught c squared. If we compare this 8th equation and this equation, in the right side what the thing we have is, here it is m squared c squared minus v squared. Here the c squared is missing, one c squared is missing. Similarly, if we look at this term, this one, if you look at this one, it is m naught squared c power 4, it is only m naught c squared. So in both the side one c squared is missing. So to equate this equation, let us multiply c squared on both the side. Multiplying c squared on both the side, we get m squared c squared minus v squared is equal to so it is squaring on both sides, means here also it is squared, we get no m naught square c power 4. Let us box this equation. This equation number 9. Now we compare the 8th and 9th equation. If we compare the 8th and 9th equation, here it is m squared c squared minus v squared. Here also we get m squared c squared minus v squared. So instead of this m squared c squared by c squared minus v squared, we can substitute this m naught squared c power 4. So substituting 9th equation in 8th. Substitute 9th equation in 8th equation. Okay, we are substituting this equation. So what we'll get? The left side will be the same, minus 2 h square nu dash 1 minus cos theta plus m naught square c power 4 plus 2h nu minus nu dash m naught c square is equal to, instead of this m squared c squared minus v squared, we can substitute this m naught squared c power 4. Therefore, we get m naught square c power 4. And what are the common terms here in both the side we have is m naught squared c power 4. So we can cancel these two terms. So here in both the side we have m naught square and c power 4. So we can cancel these two terms, and now we get minus 2h square nu dash 1 minus cos theta plus 2h nu dash is equal to 0. So we can bring it to that side and simplifying the equation we get the conclusion 2h nu minus nu dash m naught c squared is equal to, bring it to the side, we get 2h squared. The minus will be changed into plus. So, nu dash 1 minus cos theta. Is it right? Then, what are the common terms? Again, we have this 2h. So, remaining term is nu minus nu dash m naught c squared is equal to h into nu dash 1 minus cos theta. And then we can bringing the frequency term in everything in one side and remaining constant in the other side. So, therefore, nu minus nu dash by nu dash is equal to h by m naught c squared into 1 minus cos theta. So, we can split this equation. How we can split? It is nu by nu dash minus nu dash by nu dash is equal to the same term h by m naught c squared 1 minus cos theta. And what we can cancel? Nu and nu can be cancelled. Therefore, we get 1 by nu dash minus, again we can cancel nu dash, we get 1 by nu. So, 1 by nu dash minus 1 by nu is equal to h by m naught c squared 1 minus cos theta. This is the last equation in terms of frequency. But if you write in the terms of lambda, so what is the Compton shift? The difference in wavelength is nothing but Compton shift. So, we want to change the frequency terms in terms of wavelength. So, how we can change? Here it is 1 by nu dash. We want to convert it into wavelength. So, multiplying c on both sides, it is c by nu dash minus c by nu is equal to, right side also we want to multiply c. So, hc by m naught c squared into 1 minus cos theta. So, now c by nu dash is nothing but lambda dash, the modified radiation. C by nu, it is nothing but lambda, it is unmodified radiation. It is equal to, if we cancel these two, we get h by m naught c 1 minus cos theta. So, lambda dash minus lambda, that is the difference between these two, modified radiation and unmodified radiation, is nothing but dull lambda. Dull lambda is equal to h by m naught c 1 minus cos theta. This dull lambda is called as Compton shift. So, the Compton shift is based on the h by m naught c 1 minus cos theta. Let us observe this answer. H is the Planck's constant and m is the is also constant, mass of the electron is also constant and c is also constant. And what is a variable? The variable is theta. So, the difference in wavelength is depends upon the scattering angle. It is not depends upon the scatterer. So, Compton shift depends on the scattering angle. And not by the h, m naught and c, everything is a constant. So, let us find whether it is depends on the angle by 3 cases. So, we have let us assume we have 3 cases. First one, case 1, this depends on the angle. So, let us assume when theta is equal to theta is equal to 0. Okay. So what will happen? Then del lambda is equal to h by m naught c into 1 minus cos 0, cos theta, cos 0. Cos 0 is 1, automatically the change will be 0, therefore del lambda is equal to 0. So when the angle is 0, there will not be any change in wavelength. So all the scattered rays have the same wavelength, which means that is it is 0. Case 2, theta is equal to 90 degree. What will happen? Del lambda is equal to h by m naught c 1 minus cos 90 is 0. So we get the answer h by m naught c. If we substitute the value of h, Planck's constant, it is 6.625 into 10 power minus 34, and mass is 9.11 into 10 power minus 31, and for C it is 3 into 10 power 8. The answer will be 0.02424 Armstrong. So when that's a change in the angle, the Compton shift also changes. See, when the angle is 0, there is no change in the angle. But when that's a change in the 90 degree, it changes, the Compton shift also changes to 0.02424 Armstrong. So thus the Compton shift, the scattering is based on only the angle of scattering. Thank you.